If you are viewing this presentation, chances are that you are probably on a computer that is connected to the internet. Nowadays, we don't think about how our information gets to our screen as we are always used to having that information accessible. How information is routed to its destination in mere milliseconds is where routers, switches, and other network components come in. These sophisticated devices are found in over 74% of all homes in the United States. For corporations, these devices are a critical part of their infrastructure and business. In our presentation, we're going to take an in-depth look at each piece of technology that helps packets move between computers and networks. Routers are used to route traffic between LAN devices and also devices out on the internet, which are called WAN devices. When you want to browse to a website, a packet leaves your computer and heads to the switch, if there is one, and then to the router. The router in return examines the packet to find out what the destination address is and determines the best path to that device by using a routing table. They use routing tables as a map to find the fastest way to the destination the packet is looking for. Routers are typically on layer 3 of the OSI model. Switches are used to encapsulate the packet with a correct MAC address and as other network identification information to the header of the packet. Most switches now have the ability to route traffic as well. These are called multi-layer switches. Instead of sending data from a switch to a router, they act as the router and find where the traffic is supposed to go. All multi-layer switches have to have at least one static route configured that routes all traffic not locally known to the next hop router, which is typically a firewall, which in return has a next hop defined as the edge or boundary router.
At the most basic level, a server is a computer on a network that provides services to additional computers. A server can range from a high-end file server run by a large technology company such as Google, or it can be as basic as a print server that is set up in a home network. Servers provide a variety of services such as storing data in a database server, providing email routing services in a mail server, providing websites in a web server. When designing a server, they differ from desktop machines as the hardware is built to run 24 hours a day and not prone to failure. Serverless hardware contain technologies such as multiple power supplies and RAID to allow for single component failure with the server staying online.
The network firewall serves to prevent malicious attacks from external networks and protects internal sensitive information from being leaked from within the network to the internet. This internal network firewall awaits the data package after it travels from the internal SMTP server back to the router switch. An email server like that of Google's Gmail is constantly bombarded with requests for information, and for that reason, many companies use a proxy server to load data packets onto. This proxy server has the benefit of added security, plus it lessens the chance of the server from being overloaded. The proxy will then open up the packet and locate the IP address to ensure that the address is within company-established security specifications. The router then picks up the packet onto a bandwidth and guides it onto the internet. Another firewall is then initiated upon the data packet's return from the external network and is designed to let in only specifically designed packets that operate on specific ports. For example, a firewall operating on ports 80 and 25 will only accept data packets for mail, which is port 25, and packets from the internal going to the server, which is port 80. All other data packets receive the so-called quote-unquote ping of death. This stamp is received from the firewall, which then allows the entry onto the network. Providing network security starts with implementing proper network access control. Installing a firewall is only one of the many security measures that can be used to protect the network from vulnerabilities.
An Internet protocol is defined as a set of rules governing the format of data sent over the Internet or other network. In order for the Internet to function properly, each host must follow specific protocols that allow them to communicate with one another. As you can see, different protocols are used at different levels of the OSI model. One common protocol is HTTP, or Hypertext Transfer Protocol. HTTP is used by your web browser to request information from web servers by following a specific form. When the web server receives the form, it responds accordingly. Once the browser has communicated with the web server using HTTP, it uses TCP or UDP to send the actual data. TCP stands for Transmission Control Protocol and is connection-oriented, meaning that it establishes a session that monitors and ensures that all of the packets of data arrive without error. UDP stands for User Datagram Protocol and is mainly used over TCP for its speed advantage. Because UDP is sessionless, data can be transferred more quickly but without error correction. UDP is typically used for video messaging, internet gaming, and other forms of data transfer that can handle minor packet loss. A common analogy that helps describe these protocols is that TCP and UDP are trucks that transport cargo such as HTTP to and from the web server. Trucks need directions to know where they are going, and that is what IP, or Internet Protocol, is for. As data is broken down into packets and transported by TCP, IP handles the addressing for each packet and makes sure that it's sent to the correct location. IP is what makes the Internet possible.
Network media is the actual path over which an electrical signal travels as it moves from one component to another. The media, or medium, that can be used are limited into two different classifications, physical and wireless. Both forms provide decent data transfer, but they depend on internet and processor speeds as well as your router. Wireless media is pretty self-explanatory on how the data would be transferred. And also because we live in a fast-paced, high-tech world, and that's always expanding and giving new high-tech ways for us to receive media. But there are various forms of physical media that we would like to use in some offices or in our home desktop router setup, such as coaxial cables. These use a single conductor in the middle of a cable. The central conductor is surrounded by an insulator called the dielectric and is covered with a conductive shield to prevent interference. These cables are being used to deliver high-speed cable from our remaining cable companies. Confusing, yes, but yeah. Here we have both shielded and unshielded twisted pairs. The most common types of media that we see today, actually. It consists of 4 twisted pairs of wire, each with a different number of twists per foot, all encased in one sheath. Our shielded cables reduce the noise made and increase the overall performance of the device sending or receiving the data. In some cases, we have fiber optic cables, sometimes called waveguide or light guide because it guides the light waves along the length of the cable. This is a multi-mode cable. Multi-mode is used for shorter distances because of its ability to decipher multiple waves of light. The ones that you probably see are the aerial fiber optic cables. Sorry. Single modes for fiber optic cables, in the aerial sense at least, can be used to cover greater distances due to the lack of interference from other light sources. Our duct and underground can also be used, but not really seen too much these days because of where they're located.